Welcome to another deep dive. Today we're exploring something even more dazzling than fireworks.
Oh, wow.
The ultraluminous light coming from black holes. We'll be looking at an article from scitechdaily.com.
Okay.
It's called Black Hole Spins Unravel the Mystery of Ultraluminous Light. It was just published on November 7th, 2024, so you probably already know. Black holes have these swirling disks of matter.
Right, accretion disks.
Yeah, exactly. Accretion disks. But what's so special about these ultraluminous ones is that they can outshine entire galaxies.
Yeah, that's what makes them so interesting to us. They're like these extreme cosmic laboratories. We can study physics at its most extreme and try to figure out how black holes grow and how they affect the galaxies around them.
So the article talks about how these disks are like the ultimate energy converters in nature. They take gas and dust and turn it into this blinding light and powerful jets of plasma. But it gets even more interesting. Imagine a spinning top.
Okay.
And it starts to wobble as it slows down. Well, new research suggests that as a black hole spins, its accretion disk wobbles too.
Yeah, that wobble is called precession. And it actually helps explain something we've been puzzled about. Why the light coming from some of these disks seems to change. You know, it's like a lighthouse, but with a beam that's a little bit off kilter.
Wow, that's a great analogy. So we've got these black holes putting on these cosmic light shows, and now we're finding out the dance moves are even more complex. But how did scientists even figure this out? It's not like we can just fly over and take a look.
Right. We have to use very powerful computer simulations. Based on Einstein's theory of general relativity, they're basically trying to predict how every single particle moves in this swirl around a black hole.
Wow. That's amazing. So the article says that these researchers, they specifically looked at ultraluminous accretion disks, the brightest of the bright. So that means the black holes at the center must be spinning super fast.
Exactly. And the spin of a black hole is really important. It's like its fingerprint. It tells us how it formed and how it affects the galaxy around it.
Like a cosmic detective story. But the research doesn't stop there. These researchers want to compare their models to actual observations of black holes.
Right, that comparison is so important. If they can match their simulations to what we see, it'll prove their understanding of black hole physics is on the right track.
So it's like checking their homework. And speaking of homework, these researchers are using some of the most powerful supercomputers in the world, like Fugaku. I think that was the fastest until just recently.
Yeah, it's incredible how technology is helping us study these things. We can visualize stuff that we could only imagine before.
Like having a front row seat to the most extreme physics experiment in the universe. But even with all this technology, there's still so much we don't know, like how these ultraluminous disks form in the first place.
Yeah, that's a big one. We have some theories, but no definitive answers yet.
And what about the role of magnetic fields? We know they're important. But how do they shape those jets? And how do they affect the matter around the black hole?
Yeah, it's like trying to understand a cosmic hurricane full of these invisible forces.
And then there's the biggest question of all. What happens inside the event horizon?
The point of no return.
What happens to the matter that crosses that line?
That's a question that's been bugging scientists for ages.
So we have these ultraluminous accretion disks, powered by rapidly spinning black holes, putting on a cosmic light show that can outshine galaxies. And we're using these cutting-edge simulations and observations, trying to figure out how it all works. But the deeper we go, the more we realize there's so much more to learn.
That's the beauty of science.
Yeah.
Always discovering something new.
Exactly. So let's take a short break. And when we come back, we'll dive even deeper into the connection between black hole spin and those amazing jets. Welcome back. So before the break, we were talking about those big unanswered questions about black holes and those super bright disks, those ultraluminous accretion disks. It's just crazy to think something we can't even see, like the spin of a black hole, can affect the universe so much.
It really is amazing. And that's where these simulations are so important. They're not just pictures. They let scientists predict how these disks will act. And then they can actually test it out.
So it's like a cosmic roadmap. And astronomers use their telescopes to check if they're going the right way.
Yeah, exactly. The article even mentions that. These researchers are already comparing their simulations to data from real black holes. It's kind of like, imagine you're trying to find a suspect using fingerprints.
Okay.
The simulations create a fingerprint for each black hole based on its spin and how its disk is behaving.
And then they compare those fingerprints to the light patterns we actually see to see if it matches.
Right. It's like a cosmic game of whodunit.
I like that, a cosmic whodunit.
And if the fingerprints match, it means we're on the right track with black hole physics. But it gets even more interesting when you think about how a black hole's spin actually changes the structure of its disk.
Oh, okay. So like a figure skater, when they pull their arms and they spin faster.
You got it. A faster spinning black hole pulls the inner edge of its disk closer, so it becomes smaller and denser and hotter, and that means even more energy is released.
So it's like turning up the heat on a stove. No wonder these disks are so bright.
And it's not just about the light show. This connection between spin and energy is super important for how supermassive black holes grow.
Oh, right. We talked about how black holes grow by eating the matter around them, but how does the spin affect that?
Well, think of it this way. A faster spin means a more efficient feeding frenzy. The matter gets pulled in faster, so the black hole gains weight more quickly.
So these ultraluminous disks, they're not just putting on a show, they're actually helping the biggest objects in the universe grow.
Exactly. They're a key part of understanding how these massive black holes formed.
Okay, so we've got these black holes spinning like crazy for their super bright disks, and they're getting bigger and bigger. But what about those powerful jets? I'm still trying to understand how those work.
Yeah, they're one of the most mysterious things out there. But we are starting to understand them better. And guess what? Black hole spin is a big part of it again.
So the spin controls the light show, it controls how the black hole grows, and it controls those jets too.
It's like a chain reaction. The fast spin powers the disk, and the disk helps launch those powerful jets.
So how does that work? How does the disk launch the jets?
Think of the disk like a giant dynamo, creating these really strong magnetic fields. As the matter swirls around, and those magnetic fields act like a slingshot, channeling the jets outward, sometimes for thousands of light years.
Thousands of light years? That's incredible.
I know. It's not just the area around the black hole. These jets can travel really far.
So the faster the black hole spins, the more powerful those jets become.
Exactly. We call that collimation. Think about a flashlight. If the beam is spread out, it's not very strong.
Right.
But if you focus it into a small spot, the light gets much stronger.
So a faster spinning black hole creates a more focused jet, like a laser beam.
Yes. And that jet can travel farther and have a bigger effect on its surroundings.
And what kind of effects are we talking about?
Well, these jets can be like giant brooms, sweeping through gas and dust. They can cause new stars to form in some areas and stop star formation in others.
Wow, so it's like the black hole is sculpting its galaxy.
But that's a great way to put it. And the intensity and direction of those jets depend on how fast the black hole is spinning. It shows how these unseen forces can shape the whole universe.
This is also fascinating, but it also makes me wonder, could a black hole be dangerous to Earth?
That's a good question. They have a reputation for being these all-consuming monsters. But the good news is, their influence is actually limited. They mostly affect things close to them.
So we're safe, unless we somehow get too close to a black hole.
Exactly. The nearest one we know of is thousands of light years away, so you don't have to worry about Earth getting swallowed up.
Okay, that's good to know. But what about those rogue black holes you hear about? The ones that just wander around eating everything?
Those are theoretically possible. But space is so vast. The chances of one bumping into us are tiny. You're more likely to get struck by lightning multiple times.
Okay, so no cosmic vacuum cleaners coming for us. But that doesn't mean we should stop studying them.
Of course not. Black holes teach us about the fundamental laws of physics. They're like extreme laboratories. We can learn how matter and energy behave in the most extreme conditions.
It's like pushing the limits of what we know. Who knows what we might find?
Yeah. Maybe new sources of energy, or new ways to use gravity, or even completely new types of matter.
That's amazing.
But before we get too carried away, you mentioned something in the article caught your eye.
Oh, yeah. I was really interested in the description of those jets, like cosmic fire hoses, blasting matter and energy for thousands of light years, affecting entire galaxies.
They really are shaping the universe.
But I'm still wondering, how do they escape the black hole's gravity? If nothing, not even light, can escape the event horizon, how do the jets get out?
That's a great question. The jets actually aren't formed inside the event horizon. They come from the disk of matter just outside it. It's a chaotic region where the black hole's gravity is pulling in. But the matter is also spinning outward.
So it's like a tug of war, and the jets are winning.
I like that. It's a cosmic struggle between powerful forces.
Okay, that makes sense. But where does all the energy come from? For the jets and the light and the heat?
It all comes from the matter falling into the black hole. As the matter spirals in, it gets squeezed and heated up. And that releases a ton of energy.
So it's like a giant cosmic furnace?
Exactly. Turning matter into energy. And the faster the black hole spins, the more efficient it becomes.
It's incredible how much power these black holes have. But I'm still fascinated by that image of the wobbling disk. Why is that tilt so important?
Ah, the tilted disks. They add a whole new level of complexity. See, not all disks are perfectly flat. Some are tilted at an angle.
Like a spinning top that's off balance.
Exactly. And that wobble changes the light and jets coming from the disk. It's a more complicated dance.
So it's not just spinning, it's spinning and tilted.
Right. And that makes it even more interesting to study. It's constantly changing and showing us new things about the universe.
Got the cosmic ballet.
I like that. The black hole is the choreographer, and the tilted disk is the dancer.
But even with all this beauty, there's still a lot of mystery. The article said that scientists still don't know for sure how those tilted disks form in the first place.
That's true. We have some theories, but no definite answers.
So what are some of the ideas?
Well, some scientists think the tilt could be caused by other objects around the black hole, like nearby stars. Their gravity might nudge the disk.
So the black hole's dance partners are messing up its moves.
Uh-huh. Yeah, something like that. Others think the tilt might be there from the beginning, like a birthmark.
Showing us something about how the black hole was born.
Exactly. And these are the questions that keep scientists going, trying to find new ways to study these amazing objects.
It's a reminder that there's always more to discover.
Absolutely. Oh, and there was one more thing in the article that I found really interesting. It mentioned the possibility of detecting gravitational waves from these tilted disks.
Gravitational waves? I thought those were from huge events, like when black holes collide.
You're right. Those are the strongest ones we've seen. But even the wobble of a tilted disk can create these ripples in space-time.
It's like the black hole's dance is making music.
Kind of.
But these gravitational waves would be really faint, hard to detect.
Yeah, but if we could find them, it would be a whole new way to study black holes.
Like a new sense.
Exactly.
Yes.
A new way to see the universe.
That would be incredible.
It would be a revolution. But we have to be careful. We can't just get carried away with theories. The article emphasized that. We need to test these simulations with real observations.
Right. We can't just rely on models, no matter how cool they are.
Exactly. We have to compare them to the real world.
So like a trial by fire, to see if our theories can survive.
I like that. It's how we build a true understanding of the universe.
So we have these simulations predicting how tilted disks should behave, and now we need to use telescopes to see if it's actually true.
That's where the real excitement begins. The article mentioned some new observations coming up, specifically designed to look for these tilted disks.
Wow. So we're entering a new era of black hole observation.
I think so.
Who knows what we'll find?
It's a reminder that the universe is full of surprises.
Absolutely. But before we get too far ahead, let's go back and recap. What have we learned so far about these ultraluminous accretion disks?
Okay, good idea.
First, the spin of a black hole is super important. It powers those bright disks, and it controls those jets.
Right, and the tilt of the disk makes things even more complex. It makes the light and jets change in weird ways.
And we talked about the event horizon, that point of no return, and how those jets somehow escape from just outside it.
Yeah, and we can't forget how those jets affect galaxies, shaping them over huge distances.
It's amazing how connected everything is.
It really is. Yeah. But we still have so much to learn about how these disks form and the role of magnetic fields and what happens inside the event horizon.
Yeah, so many mysteries still out there.
That's what makes it so exciting.
It's that drive to learn more that keeps science moving forward.
I agree.
So let's take a short break, and when we come back, we'll wrap up our deep dive with some final thoughts.
Welcome back to our deep dives into black holes and those incredible ultraluminous accretion disks. It's been a wild ride learning about these cosmic powerhouses.
It really has. Those jets are just mind-blowing. Imagine a black hole shaping entire galaxies.
Yeah, it's like a cosmic artist. But before we get too carried away, I wanted to bring up something we talked about earlier, the supercomputers.
Oh, right. Those are essential for this research. Scientists are using some of the most powerful computers in the world, like Fugaku, to simulate these complex black hole systems.
Yeah, it's amazing they're creating virtual universes inside a computer.
And they're not just for show. These simulations make predictions about how the disks should act. So we can check those predictions against real observations.
Exactly.
It's like getting a glimpse behind the scenes of the universe using these simulations.
And as those simulations get better and our telescopes get more powerful, we're going to learn so much more about black holes.
It's a really exciting time. But like we've been saying, every answer leads to more questions. Like, we still don't know for sure how these ultraluminous accretion disks form.
Yeah, that's a big one. Some scientists think that the tilt of the disk might be important for how they form.
But we need more research.
Definitely.
And then there's those magnetic fields. We know they're there, but how do they affect everything? How do they shape the jets?
It's like trying to untangle a cosmic web. These magnetic fields are interacting with superheated gas and dust, all swirling around the black hole.
Wow. It's mind-boggling. And of course, the biggest mystery of all. The event horizon.
That boundary of no return.
What happens to the matter that crosses it?
That's the question that keeps everyone up at night.
It really does. It makes you think about the limits of our knowledge.
And it pushes us to keep exploring.
Exactly. So as we wrap up this deep dive, I want to leave you with something to think about. We've seen how the spin of a black hole, something we can't even see, can affect light and matter, and even the evolution of entire galaxies. So what other invisible forces might be out there, shaping the universe in ways we don't understand yet?
That's a great question. It reminds us that there's still so much to discover.
So keep your curiosity alive, keep asking questions, and keep looking up at the stars.
Absolutely.
Thanks for joining us on this deep dive. Until next time, keep exploring. And never stop wondering.